In this video, we're going to explore the area of equilateral triangles. So in this particular activity, we have an equilateral triangle. We're going to follow some steps to develop and derive the formula that we can use to find the area of an equilateral triangle, which, again, is kind of a shortcut. It is a triangle, so we can always use 1/2 base times height if it's more appropriate. So in step 1, or step A, I guess, it says write the degree measure of each angle in the triangle. So the fact that we know it's an equilateral triangle will tell us that it's also an equiangular triangle, because it's just a property of equilateral triangles. So then all the angles are going to be the same. There are 3 angles, and they all add up to 180 degrees. So they're all going to be 60s. Because again, they're congruent. Sides are congruent, angles must be congruent as well. Step B says draw an altitude from the angle at the top. So we're going to go to the top of that triangle, drop our altitude in. And because it's also not just an equilateral triangle, it's an isosceles triangle, the altitude that we drew in is also going to bisect the base. So it's a median as well. So what ends up happening is that side at the base that was an S now breaks up into 2 pieces that are S over 2. Or if you want, you can think of it as 1/2 S. It's the same idea. Actually, let's just write it as 1/2 S because I think that's a little more intuitive than S over 2. All right, 1/2 S, 1/2 S. Okay, so what does this do to the side at the bottom? Again, when we drop that in, that's going to bisect it. Label the triangle with this new information. So now that we have this new information, we're going to try and determine the height of the triangle. So if this angle here was 60 and it's been bisected, that's now going to give us 30s. What we've created then is a 30, 60, 90 triangle. And the bottom here, again just translating that side over, is 1/2 S. And the side here is S. And we know that in an equilateral, in a 30, 60, 90 triangle, the sides are in the ratio of, let's write this out, 30, 60, 90 gives us an x, x root 3, and 2x. What we're looking for is the side across from the 60-degree angle. So our 30-degree side is 1/2 S. The 60-degree side is that times root 3. So this height would give us that, 1/2 S root 3. In D, then, we're saying, okay, well, it is a triangle. We can use the formula 1/2 base times height. What's the base, what's the height, and plug them into the formula. So let's do that in a slightly different color. I'm going to take 1/2. This is our side, that's our base. And our height we just found in this step was 1/2 S root 3. That's kind of a disgusting formula, so let's kind of clean it up a little bit and see what we can do. We can take 1/2 times 1/2, which would give us 1/4. We can take S times S, which would be S squared, and then we have our root 3. That formula can be used to find the area of an equilateral triangle if you know the measure of one of the sides. And again, all the sides are going to be the same. So that's an important one for us to remember. Let's do a couple of practice problems with this and kind of wrap it up. Let's look at number 2. We have 4 meters. We want to find the area of each triangle. Write our answer in simplified radical form, and you include units in the answer. So in this case, our side is 4. We know it's equilateral because all these marks kind of show that we're going to have an equilateral triangle. So we can use that formula that we just derived and find the area. So we're going to take 1/4 of, the side is 4, squared root 3. So 1/4 of 16 times root 3 would give us 4 root 3 meters squared. So a direct application if we have the side. Number 4 is what I'd like to take a look at as well, because we're giving kind of a little different piece of what this is all about. Now, if we have two 60-degree angles, our assumption here is that the third one will also be 60 because that would make 180 degrees. Now this side right here, if it divides it up, would make our 30, 60, 90 triangle. we have the side that's across from the 30, that's 4 inches. But in order to find apply the area, or the area of an equilateral triangle formula, we have to know what one of the sides equals. We don't quite know that yet, but we can quickly find it by doubling that side across from the 30. So that would give us 8. So when we find the area of this one, it's 1/4 of 8 squared times root 3. 8 squared is 64. So this gives us 16 square root of 3 inches squared. 5 is a little bit more challenging because we don't have a side that's easy to work with, in my opinion. We have the side that's across from the 60. Once again, we're looking at a 30, 60, 90 triangle. So we've got the 6 root 3 that's right here. If we redrew this triangle, we've got our 90 here, our 60 here, and our 30 here. This is our 60. What we're trying to find is this hypotenuse, because that'll tell us what the side is. We may or may not need that. We'll take a look. So we know that that 60 is equal to x root 3. So you might be able to quickly find out that x is equal to 6. And if you can't, you can always rationalize it, or there's a way to do this by multiplying both sides by square root of 3 and dividing by 3, and you're good to go. But this part right here is going to give us 6. What that means then is this entire thing is 12. We have a choice. There's not necessarily a wrong answer to this, but we can use the formula 1/4 s squared root 3 because it is an equilateral triangle and use 12 as our side. But we already have the base and the height, so it might just be easier to use 1/2 the base times the height. And that would give us 36 root 3. And we're talking about feet squared. And in the last problem here, the area of an equilateral triangle is 16 root 3. Find the height of the triangle. So in order to do that, I think I'm going to need to find out what the side equals. So I'm going to use the formula for the area of the equilateral triangle, but we'll work backwards. So it's 1/4 s squared root 3, and that's supposed to equal 16 square root of 3. If you take a look at the left-hand side and the right-hand side, you'll notice that they both have a root 3. So I can essentially cancel those out by dividing through by root 3. So when I have 1/4 side squared equals 16, I'm going to multiply both sides by 4, and my side squared is 64, so side is 8. But I'm asked to find the height of the triangle. So to do this, I'm going to draw in my equilateral triangle. Again, side of 8. Drop your altitude, because that's what we're trying to find. There's our 60 and our 30. If this is 8, then this part here would be 4. And then this is the root 3 component. 4 root 3 centimeters. All right? So again, just a couple of different looks at equilateral triangles, but again, that formula 1/4 side squared root 3 can go a long way in helping us quickly and easily find the area of equilateral triangles.